The Moon is the Earth's closest space neighbor and its only natural satellite. It likely formed when a huge Mars-sized object crashed into our planet billions of years ago. I wasn't around then. This catastrophe turned Earth into a scorching ball of molten rock. It also pushed some material into its orbit, creating the Moon. Now, this heavily cratered sphere moves around our planet. This causes high and low tides around the globe. A bit more than 1/4 the size of Earth, it's the 5th largest natural satellite in the solar system. The Moon has several phases. For example, new, full, or crescent moon, first and last quarter. But whatever the satellite looks like, you can always find it in the night sky, and sometimes even during the day. But imagine waking up at night and noticing that the Moon looks somewhat different than usual. It seems brighter and bigger. It's hardly noticeable, especially when you're half asleep. You go back to bed, unaware that instead of the Moon, you've just seen Mercury. Close up, this planet, the nearest to the Sun, is similar to our natural satellite. Its surface is littered with craters left by space rocks. Mercury is about 2/5 the size of our planet, but it's still a bit larger than the Moon. That's why the planet would have a greater influence on Earth. Nights would become brighter. High tides would become higher, and low tides, what do you think, lower? Yup. The lunar cycle, that's the time the Moon, or rather Mercury now, needs to go through all the phases, would become 14 hours shorter. But all in all, such a replacement wouldn't have any drastic consequences for our planet. But then, how about Venus? What if, instead of the familiar satellite, we swap in the third brightest natural object after the Sun and the Moon? It's often called Earth's sister planet because their mass and size are nearly the same. Venus would be as large in our sky as Earth once appeared to the Apollo astronauts when they looked at it from the Moon's surface. The morning star would be much brighter than the Moon. For one thing, the planet reflects 6 times more sunlight. Plus, it would occupy an area at least 16 times larger. That's why nights on Earth would be as bright as early twilight now. If you looked at Venus, you'd spot vague swirling patterns in the planet's yellowish-white cloud cover. Venus wouldn't become Earth's satellite. The two planets would likely orbit around their common center of mass, and this orbit would be quite eccentric, like me. But if Venus moved with the same speed as the Moon has now, the two planets would crash into each other in the nearest future. Uh-oh. Okay, let's pull another switcheroo. If Mars was up there in the sky instead of the Moon, you'd surely notice it. Even without a telescope, you'd be able to marvel at its unusual color and dark spots on its surface. And even if you didn't see the red planet, you'd still feel something unusual. Mars is half of Earth's size, but several times larger than the Moon. Replacing a smaller space body with a much bigger one would upset the delicate balance on our planet. If you were unlucky to be at the seaside when Mars took the Moon's place, you'd have to evacuate as soon as possible. Massive waves would rise in the oceans under Martian influence. They would crash against the shoreline like the largest tsunamis. Mars would be reflecting more sunlight than the Moon. Nights would be lighter. Terrestrial landscapes would have an eerie red tint. And you'd be able to admire the tallest mountain in the solar system, Olympus Mons, through a telescope. Mars isn't large enough to change the Earth's orbit dramatically, but with time, the two planets would probably begin to orbit each other, creating a binary planet system. And since Mars would literally be next door, voyages to this planet would become a reality. Okay, now think really big. If Jupiter replaced the Moon, Earth, as an independent planet, wouldn't exist anymore. It would instantly turn into another moon of the largest planet in the solar system. The only positive moment in this transformation? People would have an awesome sky view. Jupiter is dozens of times larger than the Moon. A gigantic, beautifully striped sphere would cover nearly all the horizon. If you had time to enjoy the show, you'd see yellow, brown, red, and white clouds floating in Jupiter's atmosphere. Sadly, the gas giant's gravitational pull would instantly cause severe earthquakes, volcanic eruptions, and tsunamis. Earth's mantle and crust would be drawn toward Jupiter, which would break the planet apart. It'd be stretched and compressed with such force that its surface would bulge back and forth by more than 300 feet. Unfortunately, Earth's speed is only 10% of the speed needed for us to stay in Jupiter's orbit. That's why our sluggish planet would crash into the gas giant in less than a day. Well, that sounds unpleasant, so let's not do that. Now, if Saturn were to replace the Moon, it would be a sight to behold. The planet is more than 35 times larger than our satellite. It means the giant golden globe would cover 18 degrees of the sky, and its rings would stretch even further, from horizon to horizon. Hey, if you like it, then you should have put a ring on it. Earth would be a bit further away from the gas giant than its own moon, Dione. And since Saturn is way more powerful than our planet, Earth would turn into its satellite, not the other way around. Unfortunately, Earth's rotational speed wouldn't be enough to keep up, and we'd most likely crash into the much larger planet within a day or two. But before burning up in Saturn's atmosphere, we'd have to pass through its magnificent rings. They're made up of pieces of comets, asteroids, and shattered moons. It wouldn't be an easy feat to get through this space debris. Plus, our planet would have to avoid Saturn's moons, all 53 of them. But what if the fall didn't happen, and Earth did turn into Saturn's 54th moon? Then the gas giant's gravitational pull would lead to massive tectonic shifts all over our globe. They would be tearing the planet's crust apart until there's nothing left. Not good either. Both Uranus and Neptune are ice giants. These planets are the same size, larger than Earth, but smaller than Saturn and Jupiter. They both have icy interiors, deep atmospheres, and similar color. Very beautiful bluish-green. If either of these planets replaced the Moon, the consequences would be the same. So, let's flip a coin. Okay, it would be Neptune you'd see in the sky one day. Neptune is 14 times larger than the Moon. The planet would look like a bright blue hot air balloon in the sky, not only at night but during the day too. It would appear to be 15 times larger than the Sun. If everything else remained the same, a solar eclipse would seem to continue for ages. Once the Sun vanished behind Neptune's edge, our planet would be plunged into complete darkness for no less than an hour and a half. Neptune is 17 times the mass of Earth, and its gravitational pull is much stronger. That's why our planet would end up as a satellite. Yep, again. It would orbit Neptune slightly further than its own largest moon, Triton. By the way, there would be a great risk of Earth colliding with this space body. But let's assume we were lucky enough not to cross paths with Neptune satellites. Even so, there would be more than enough problems on our hands. Tides on our planet would become 1,000 times more powerful than those caused by the Moon. Neptune's gravitational force wouldn't pull Earth apart, but it would heat our planet up. The seismic activity would increase, setting off earthquakes and volcanic eruptions. And probably louse up the internet too. Dark, mysterious, cold space. Comets, asteroids, planets, stars, and something that's lurking over there, far beyond Pluto. Yup, this could be the 9th planet of our solar system, the one people have been wondering about for centuries. IRAS, which stands for the Infrared Astronomical Satellite, collected interesting data back in 1983. It could be proof that Planet 9 is hiding there. No one knows if it really exists, but this discovery helped to build a model to understand this potential planet better. And in 2016, scientists found out that some small space objects in the Kuiper Belt were orbiting a bit oddly. The Kuiper Belt is the outer area of our solar system. It's a ring in the shape of a donut, filled with leftovers from the times when our solar system was forming. You can find this donut beyond Neptune. The objects in that region of space have weird orbits, almost as if a big body with strong gravity is pushing them away. Knock knock, Planet 9 again. The theory says it might be 5 to 10 times the mass of our own planet and up to 20 times further away than Neptune. The astronomical unit equals the distance between our planet and the Sun. Pluto is approximately 40 astronomical units from the Sun, but Planet 9, if it exists, is 400 to 800 astronomical units away. It would take 10,000 to 20,000 Earth years for this mysterious planet to make a single circle around the Sun. This makes it harder for us to catch this space body. There's a theory Planet 9 may have formed between the orbits of Jupiter and Neptune, similar to the rest of the gas giants in our solar system. The gravitational force of one of the two huge planets probably kicked it out of its orbit. Oh no. Then Planet 9 could get ejected further away from the 8 planets we know about. It ended up as some sort of icy waste, quite small at the beginning. But as time went by, Planet 9 has cleared its orbit of frozen pieces of rock and dust and finally formed into a real planet. Another theory says that this could be a planet another star lost on its way while it was passing near our solar system. In any case, Planet 9 probably doesn't reflect that much sunlight since it's so far away. And astronomers aren't sure where exactly they should look for it. Space is dark, mysterious, endless, obviously. But if we do find Planet 9, it will be the first solid proof there are more planets in our solar system than we thought. Moving on to an interesting exoplanet, located only 90 light-years away from us. An exoplanet is generally a planet located outside our solar system. This one has an atmosphere with water clouds. 1 year there lasts 24 Earth days, and the planet travels around a red dwarf star, which is way dimmer and smaller than our Sun. That's why, even though the planet is 8 times closer to its star than we are to our Sun, the temperature there is similar to that on our planet. This exoplanet has a size similar to Neptune. It's also less dense, which means it's mostly made of gas, unlike Earth, which is made of rock. The average temperatures there is 140 degrees, which makes it one of the coolest small exoplanets we've ever discovered. And the cooler the exoplanet is, the bigger the chance we'll find clouds in its atmosphere. Researchers have discovered more than 4,000 exoplanets, but all of them have been found within the Milky Way, at least until now. For the first time, astronomers may have spotted a planet outside our galaxy. They called it M51 ULS-1. The planet is located in the Whirlpool Galaxy, a distant spiral galaxy 28 million light-years away from us. There was once a huge but pretty young star that got stuck in a gravitational dance with something that could be a dense neutron star, the collapsed core of a giant star, or a black hole. The star's dance partner had incredibly strong gravity. It was feeding on the star, greedily ripping away its plasma. Then something unusual happened. An unknown, maybe even Saturn-sized object passed by and blocked this confrontation from our solar system. Now no one can see what is going on. But this could potentially be the farthest planet we've ever discovered. There's a newly discovered planet outside our solar system. As large as Jupiter, it orbits 2 stars, and as we can observe it from our planet, it crosses in front of them both. The full circle around these 2 stars, which means 1 year, takes approximately 200 Earth days. On the day of the discovery of the previous planet, scientists also found it had an unusual companion. It's an extra-hot Jupiter with an ultra-tight orbit around its star. The year there lasts only 1.9 Earth days. This planet has a weirdly shaped orbit. Also, it travels in the opposite direction from the rotation of its star. If you could travel 57 light-years away from our planet, you'd see something pink lurking in the darkness. As you get closer, it becomes bigger and more fascinating. Yup, it's a magenta-colored planet. A few billion miles away from its sun, this guy is one of the youngest planets scientists have discovered. It's only 100 to 200 million years old. It's made of pink gas, similar to our Jupiter. So if you could fly closer to its surface, this gas would envelop you like a thick fog. You're coming closer and going deeper, and the gas is becoming darker, getting a reddish shade. And look at the planet's core. It's super hot. Because of its high temperature of 460 degrees Fahrenheit, this planet is like an oven. The heat is the reason the planet glows so brightly. You'll also notice the sky is hazy pink, with clouds made of droplets of frozen water, similar to ours. There's another exoplanet half as massive as Earth, which is one of the smallest planets we've ever found outside our solar system. It has a diameter of 5,600 miles. For comparison, Earth's diameter is 7,900 miles. The planet in question is mostly made of iron, similar to Mercury. Mercury has a massive iron core and a very thin crust, which makes it an oddball in our solar system. At its early stages, it collided with some space body at least once. That collision pulled its outer layers away, which is why only the firm iron core remained. Maybe this exoplanet participated in a huge space crash too. That's what probably took away the planet's mantle and left mostly its iron core. Or maybe this is just a remnant of a gaseous planet that used to be the size of Neptune. The atmosphere of the planet could be blown away by, let's say, a huge amount of radiation coming from the star. This planet is only 31 light-years away from us, and the day there is less than 8 Earth hours long. The planet is only a little bit bigger than Mars. People aren't likely to ever settle in that place because of its extreme temperatures that go up to 2,700 degrees Fahrenheit. There might even be molten lava on the side of the planet that faces its star. Such temperatures are high enough to evaporate any atmosphere, so this planet might have had one in the past. Generally, gas giants like Jupiter can't support life because they have extreme weather conditions, temperature, and pressure, and there are no building blocks that might create life. But smaller terrestrial planets, such as, Earth, have more key ingredients like oxygen and liquid water. Plus, they have more temperate weather and other conditions. And still, not all of such planets support life, of course. It's not easy to find a planet with similar conditions as the ones we have on Earth, or at least the conditions that would allow life to develop there. But meet Kepler-22b, one of our most promising findings. It's 600 light-years away from us, twice bigger than our planet, and with temperatures of about 72 degrees Fahrenheit. This is a so-called super-Earth. It's a category of planets unlike any we have in the solar system. They're more massive than Earth, but still lighter than ice giants such as Uranus or Neptune. Super-Earths can consist of rock, gas, or a mixture of these two. Kepler-22b is within the habitable zone of its parent star, which is less bright than our Sun. The planet probably has a rocky core. It may have an ocean, but it doesn't host any life. At least, we don't know about it yet. We all remember seeing the Apollo lunar rover on the Moon built for space missions in the 70s. Besides transporting astronauts for certain explorations, they were used for taking pictures and collecting soil samples for scientists to study. The vehicle was designed by Boeing, the company famous for building airplanes, and cost around $38 million to build. The kind of loose change you'd find today in Elon Musk's couch. In the far future, technologies will be so advanced that a regular car for the Moon will behave like a regular SUV we have today. It'll have a sleek look and might be produced by some famous car manufacturers available. Back then, the lunar rover used a T-shaped throttle to move the car left, right, backward, and forward. The futuristic one can be voice-controlled and require minimal human control. And we can't leave out the Earth roof. Hey, you really don't need a moon roof on the Moon. Anyway, the Moon's driving conditions are not that extreme compared to Mars or other planets. It's hard to believe that the first landing craft to enter Mars was Viking 1, launched on August 20, 1975. It arrived at Mars on June 19, 1976. But decades later, Curiosity, which had 6 legs and 6 wheels attached, took the stage as the cute robot explorer. It was designed for the rough terrain, so in the distant future, a human-operated vehicle can have a similar design for people who want to cruise by the Mars sunset. For any human-designed car to work on planets other than the Earth, they have to be electric or anything else that can produce an unlimited supply of energy. Gas-powered vehicles won't work in the vacuum of space, and certainly not on any planet other than our own. It can be powered by the strong sun and convert the energy to run the vehicle. The interior has to accommodate the extreme conditions on the planet, since the atmosphere is very thin and unbreathable. It has to be very warm, since Mars can reach sub-zero temperatures. The matter of gravity isn't that extreme, but frequent dust storms are the problem. The vehicle will also have wheels attached to legs to maneuver around properly, since the terrain is difficult to get around in. Now, my 2 cents here? Well, I think an all-leather interior with 6-way seats front and back will be nice. Adding a 12-speaker sound system with Are You Sirius FM radio is a must. Did I mention the Earth roof? Yeah, I did. And don't forget the 60/40 fold-down rear seats so you'll have plenty of room to haul your camping gear on your weekend escapes. Meanwhile, it's still possible to have a panoramic glass view of the interior in a project like a tour bus on Mars. There are plenty of locations to discover, like the tallest mountain in our solar system and the snowy Carbon Peaks. The Red Planet can also have an express train ride that can take you from one place to another. It'll be one of those luxurious cabins that will take you from one landmark to another since Mars becomes colonized and established. The train will also be electric-powered or powered by another power source. Mars is a place where it's possible to have all kinds of vehicles, since the conditions aren't that different from Earth's. Just don't go outside without a helmet. If we designed a vehicle for Mercury, then get ready for bright light from the sun, in which case we would need to add industrial visors and blackout strips around the glass so that the sun won't get to us. At least we won't have to worry about the heat, since Mercury isn't the hottest planet in our solar system. Well, the temperatures can reach a soaring 800 degrees on a warm sunny day and drop down to minus 300 degrees at night. The vehicle will have to have multiple layers and coatings to withstand the conditions, and it will most likely have spider legs to move, since rubber wheels will melt instantly. And to save itself from damage, it'll need to dig underground to hide from the sun and atmosphere, just like a crab or those spiders that create hatch floors. Driving a vehicle on Pluto will be very challenging, considering that it's the furthest planet from the sun. Now, Pluto is technically not a planet anymore, but it's still a large enough mass to explore. Temperatures there can reach below 400 degrees. A mere jacket won't cut it. The vehicle will need super insulation to keep the operator warm and fuzzy. Methane ice surrounds the land and covers the mountains. Gravity is also an issue since it's very weak, which will make you float in the air. Now, designing a vehicle for Pluto will be tricky. The key for it to move and not freeze will be how the legs move. It'll also have legs like the one on Mercury, but will have a lot of heat generated to keep warm. The weight is enough to keep this vehicle in place. However, that can't be said for Neptune, the windiest planet in our solar system. It's impossible to breathe in the atmosphere, and the atmospheric pressure will crush you. Designing a vehicle is challenging, considering the many external factors, and will have to be pressurized to counter the external atmosphere. It will also need a special coating to counter the harsh temperatures. And because Neptune is extremely windy, it would need some sort of anchor to keep it in place, something like a large drill that shoots from the belly of the car and digs underground. It will also have spider legs to move around, but they'll behave in a similar motion to how a camel walks. That way, it can maintain its center of gravity. Now, Venus is the hottest planet in our solar system, with temperatures reaching 1,000 degrees. The pressure will push your vehicle like a can, so it needs proper internal pressure to balance it out. This car will require all the upgrades for countering the heat. It will need proper coating, no glass, and even a special color to reflect the heat. Nothing can actually stay on the ground for too long, so spider legs won't really work. It'll need to hover slightly above the ground and float around. Now, Saturn is the second largest planet in our solar system and has a very windy upper atmosphere and very strong gravity. The rings around it are made up of ice materials that can range from the size of a pebble to the size of a school bus. The pressure is so strong that you'd be crushed the second you reach its atmosphere. Designing a vehicle would be very challenging and weird. It'll need the best technology for withstanding the crushing pressures and harsh temperatures. The vehicle will have to be large and composed of many internal layers. Since the upper atmosphere is windy, the vehicle will have to remain on the ground for as long as possible. Scientists don't know much of what the surface looks like, so the vehicle will have to be prepared to move on solid surfaces, liquid, and anything else in between. Now, I think it's called slop. It'll need mechanical arms to maneuver through the possible rugged terrain and multiple legs like a centipede. Those arms can pick up things and move them out of the way if it faces some obstacles. The long body can also detach itself and break into smaller pods for a quick escape. From what, we don't yet know. No human can step foot outside even if they wear protective gear. Robots will have to be deployed to test how human bodies can withstand the conditions. Jupiter has harsher conditions than Saturn, with the red spot being the most dangerous area on the planet. It's an extremely large area that has hurricane-like storms that have been going on for years. The vehicle will resemble that of Saturn, but extra heavy-duty. Scientists also don't know what's happening on the surface except for the crushing atmospheric pressure. The vehicle won't be able to move on the surface if it were to pass through the red spot, so it'll have to dig underground and move underneath. For that, it'll require a huge drill and many self-automated drones and vehicles that can be deployed from the main vehicle to help with digging and surveying. Once underground, it'll have legs that will help it crawl and a giant drill nose to dig further. Many of the body parts can also break off into smaller pods to get through certain terrains, but can be easily reattached. The craziest place where we can launch a vehicle is the Sun. There's no way to imagine it except being self-automated. Any human on board won't make it halfway in the journey. The launch will have to be from Mercury in a protective facility sheltered from the harsh temperatures. The vehicle will have to be made out of the best resources to withstand the extreme heat and gases and won't last more than a couple of minutes once nearby. It'll most likely resemble a satellite and float around to take some footage for us to study. It'll probably cost trillions of dollars, but the results will be worth it, won't they?